The world is on the verge of a flight revolution, one that swaps thunderous roars for peaceful skies. Supersonic travel, long admired for its breathtaking speed, is getting a silent makeover. At the heart of this breakthrough stands the X-59 Quiet Supersonic Technology, QueSST. Born from a powerful partnership between NASA and Lockheed Martin, this futuristic jet is set to transform both military and commercial aviation. No more ground-shaking booms or startled communities, just smooth, quiet journeys at blistering speeds. The X-59 isn't just fast, it's rewriting the very sound of supersonic flight. The birth of the X-59. The journey of the X-59 began in February 2016 when Lockheed Martin secured a contract from NASA to design and build a supersonic aircraft that could fly faster than sound while minimizing noise pollution. Unlike earlier designs that prioritize speed at the expense of environmental and community impact, the X-59 was engineered with a specific goal: to fly supersonically over land without producing disruptive sonic booms. Between February and April 2017, Lockheed Martin's team conducted wind tunnel tests using a scaled-down model representing approximately 9% of the aircraft's actual size. These tests simulated a range of speeds from just below the speed of sound to 1.5 times its velocity, analyzing how the aircraft would perform under varying conditions. Despite initial expectations for early 2020s flights, the project faced several delays. However, NASA now anticipates that the X-59 will begin its flight tests in 2025. How supersonic flight once failed. To fully appreciate the innovations behind the X-59, it is important to understand the history of supersonic passenger travel. The Concorde, introduced in the 1970s, captivated the world with its ability to cross the Atlantic in just a few hours. However, a series of setbacks quickly dampened its success. A tragic crash involving the Soviet Tu-144, combined with growing concerns about sonic booms and environmental noise, led many countries to restrict supersonic flights over land. By 1976, most airlines had canceled their Concorde orders. Only a few nations, the UK, France, China, and Iran, initially remained interested. Ultimately, just British Airways and Air France operated Concorde flights, and even they required government financial support. The United States also pursued its supersonic ambitions through Boeing, but in 1971, government funding was withdrawn, and the project was shelved before any prototypes were completed. Some speculate that financial and political concerns played a role in protecting domestic airlines from foreign competition. The Concorde also faced significant cost overruns. Originally projected to cost £70 million, the project ballooned to between £1.5 and £2.1 billion by the time it entered service. Concorde's technical triumphs and challenges. Despite these financial and political hurdles, Concorde remains a remarkable technical achievement. Its delta wing design allowed it to cruise at Mach 2.02, or approximately 1,338 miles per hour, at altitudes of 60,000 feet. This allowed passengers to glimpse the curvature of the Earth from the windows, an experience unmatched by subsonic flights. However, the plane consumed around 18,000 liters of fuel per hour, making it expensive to operate. The airframe, largely composed of specialized aluminum alloys, was engineered to withstand the extreme heating and cooling cycles caused by supersonic speeds. The friction of air traveling over its skin generated considerable heat, sometimes warming cabin surfaces to the touch. Engineers designed Concorde's structure to expand by nearly 30 centimeters during flight, leading to quirky anecdotes such as flight engineers leaving their hats in the expansion gaps. The plane's pressurization system mimicked altitudes of 6,000 feet, balancing passenger comfort and safety. At Concorde's cruising altitude, sudden cabin depressurization could incapacitate passengers within seconds, so backup systems and pressurized oxygen masks were essential safety features. Concorde was finally retired in 2003 after rising maintenance costs, dwindling passenger numbers following the 2000 crash. The X-59, solving the sonic boom problem. The X-59 directly addresses the primary issue that hampered Concorde's success: the sonic boom. Traditional supersonic aircraft produce loud, explosive noises when breaking the sound barrier, which can startle people on the ground and damage property. The X-59's innovative design reduces these booms to a gentle thump that is barely noticeable from the ground. NASA and Lockheed Martin meticulously shaped the X-59's fuselage and wings to minimize shockwaves. The aircraft's nose is long and slender, contributing significantly to noise reduction by spreading the pressure waves that typically merge to create a sonic boom. Unlike most aircraft, which house engines beneath the wings or at the tail, the X-59's General Electric F414 engine is embedded within its fuselage, with its air intake mounted on top. This unconventional placement prevents the interaction of multiple shock waves, further lowering noise levels. Overcoming technical challenges with innovation. While this new engine placement dramatically reduces noise, it also presents complex engineering challenges. Airflow over the fuselage becomes turbulent before reaching the engine intake, potentially reducing engine efficiency or causing instability. NASA's engineers address this issue with advanced airflow management technologies. One of the most remarkable adaptations is the absence of a traditional forward-facing cockpit window. The X-59 relies on an advanced external vision system that uses a 4K front-facing camera combined with a digital display inside the cockpit. Building the X-59. Progress on the X-59 accelerated in 2019 when Lockheed Martin's Skunk Works completed the critical design review, signaling that the aircraft was ready for production. By the end of that year, over 80% of the engineering drawings were cleared for manufacturing. In May 2019, assembly of the first major components began in Palmdale, California. NASA also tested the external vision system using a King Air aircraft as a flying test bed. Subsequent wind tunnel experiments focused on optimizing the engine's air intake, ensuring reliable performance across a wide range of speeds. By November 2022, engineers installed the powerful General Electric F414 engine, capable of producing 22,000 pounds of thrust. Weighing approximately 32,000 pounds fully loaded and stretching 100 feet in length with a 30-foot wingspan, the X-59 is built for both speed and stability. In August 2023, Lockheed Martin showcased the completed aircraft as it rolled out of its hangar. The stage is now set for the jet's inaugural flight in 2025. A global shift in air travel. The X-59's true significance lies not only in its impressive engineering, but in its potential to transform global air travel. Current international aviation regulations prohibit supersonic flight over land due to noise concerns. NASA's ongoing community response tests, scheduled between 2023 and 2025, aim to demonstrate that the X-59's quiet supersonic flight is safe, sustainable, and acceptable to the public. Data gathered from these community tests will be submitted to the Federal Aviation Administration (FAA) and the International Civil Aviation Organization (ICAO) by 2027. If successful, new regulations could emerge by 2028, potentially allowing commercial supersonic flights over populated areas for the first time in decades. Such a development could slash travel times drastically. A journey from New York to Paris could be completed in under 3.5 hours, compared to the 7-hour duration on today's subsonic aircraft. Flights from London to Sydney could take just a few hours, bringing distant continents closer together than ever before. The military implications of quiet supersonic flight. While much of the attention surrounding the X-59 centers on commercial possibilities, military strategists are also watching closely. Supersonic military jets often create deafening booms when breaking the sound barrier, which can compromise stealth operations or alert adversaries. If the noise generated by supersonic flight can be nearly eliminated, this opens new doors for defense applications, surveillance, and rapid deployment without detection. Both China and Russia have expressed interest in developing similar technologies, as quiet supersonic flight could provide a tactical advantage in future conflicts. Make sure to smash that like button and subscribe for more cutting-edge tech stories. Don't forget to hit the bell icon so you never miss our latest uploads. The skies are changing, and we're here to bring you every breakthrough.